My discussion question, it was talking about the z-test for proportion and, excuse me, the using two samples to find proportion. So this is from chapter 20, and what I decided to do was use the same material from lecture, which was looking at condo sales during the ski season. So step one, we're just going to define what we're looking at, and I wanted to know if the proportion of condo sales near ski season had changed over the course of years. So I'm looking at old sales, and I'm defining those as, which this disappeared apparently, 2009 to 2013. And then my data is a little bit different. I think I copy and pasted it wrong, but I adjusted for it, so it's fine. And then the recent is 2014 to 2017. So our null hypothesis is going to be the boring, as in the old proportion of sales during ski season is going to be equal to the recent sales, aka it has not changed. And the alternative is going to be that they're not equal or it has changed. So then we're going to go into step two, which is we're going to make sure that it's appropriate. Nothing ties these two samples together, so they are independent samples. As far as being independent observations and independent random samples, they're all condo sales in a particular development, but we have to look at, is this typical of the population that we're looking at it? So we're going to go ahead and continue. And then we're going to look at the success failure condition. So just if there's 10 successes and 10 failures. So in order to decide that, we wanted to go down here, and I made these little tables. I just set up the number of near ski season sales, which was defined as October through March, and then off-season ski sales, which were the rest of the remainder of the month. So for me and my data from copying and pasting wrong, I ended up with 26 that were in the ski season and 29, which ended up being 47% success rate and 36% success rate for recent sales. So if we look at that, we can see that 55 of those, because that was the total sales for old, times 0.47 was 26, so that means we have more than 10 successes and more than 10 failures. And 28 times 0.36, because that was a percentage of successes, is 10.08. So we had at least 10 successes and then, of course, more than 10 fails. So the next step that we're going to look at is how far away our sample difference is from the population parameter difference, which was just our null hypothesis. We said they were equal right here. But in our data, we got 0.47, 47% minus 36%, which gave us 0.11. So then we want to find the standard error, so how much noise is in the system. And in order to do that, we're going to take that 0.47 times 0.53, p hat times q hat, success times failure, and we get 0.249, and then over here we're going to take 0.36 times 0.64, and it actually gives us 0.230, but it cut off the 0. And then after we do that step, the next step to get to the standard error is that we are going to take this total here divided by the total sample size. So that ended up being 0.0045 when you take 0.249 divided by 55, and 0.23 divided by 28 was 0.0082. So then what we're going to do to find the standard error is we're actually going to add these numbers that we got here together, and then we're going to take the square root of those sums, and that's going to give us our standard error, which in this case is 0.1127. So we see that this is our standard error, how much noise we have in the system, and then we're going to make a ratio of the two quantities, our sample difference and then the noise. So we're going to take 0.11 minus 0 and then divide that by our standard error of 0.1127, and that is going to give us our z-test statistic, which is 0.976. So if we go down here, we can see that our Z-test statistic on the normal bell curve hits about right here. There's quite a bit on both ends of the tail. So in order to get our p-value, we're just going to go over to Chrome here real quick. We're going to scroll down and we are going to look in the area outside Z and Z and find as close to 0.97 as we can get, and that's 0.95, and then that gives us our p-value, which in this case is 0.342. So we're going to go back over here, write down our p-value, and the next step is to make a decision. I'm defining alpha as 0.05, which is pretty typical for significance. So for us, that means we're going to retain the null hypothesis because our p-value was not smaller than 0.05. So in conclusion for this, what I said was the evidence suggests that the proportion of condo sales that are near ski season did not change from old sales to recent sales, aka the proportion of condo sales near ski season has stayed the same. Okay guys, I think that's everything. If anybody has any questions, let me know.